Welcome to assembly language programming. The next program we are going to see is addition of two 8-bit numbers. In microprocessor 8085, we are going to use a simulator called GNU Sim 8085. The program we are going to discuss is addition of two 8-bit numbers. Right. So what are we going to do here is we are going to take two numbers, add those two numbers and store the number in another memory location. The first number is going to be present in memory location 1100. The second number is going to be present in memory location 1101. I'm going to add these two data values and I'm going to store it in memory location 1102. So I'll be storing it in memory location 1102. Right. So what happens is here there are two cases. The first case is when I add two numbers, I will get a carry. This is case number 1. Let us say case number 1 is when I add two numbers, I may get a carry is case 1. Case 2 is I may not get a carry. Right. So when I add numbers 3 and 4, 3 plus 4 is equal to 7. So 3 when I have to represent 3 in let us say binary. So how will I represent 3 in 8 bits? 0, 0, 0, 0. I'm going to say 0, 0, 1, 1. That is how I represent 3. Right. So let us say another number I have taken here is 4, 0, 0, 0, 0. So I'm going to represent 4 as 1, 0, 0. When I add these two numbers, what I'm going to get is my output is going to be 7, which is going to be 0, 0, 0, 0, 0, 1, 1, 1. So this is my output. See, I have given two numbers, two input numbers, both are 8 bits. Right. So I'm getting an output. That output also can be represented within 8 bits. Okay. If you are able to represent the sum of two numbers in 8 bits, the result of adding two numbers, if it is going to be just 8 bits, then there is no carry. This is one case. The other case is I am going to add two 8-bit numbers only. See the two numbers in the other, the next example what I have taken is I have taken two numbers, say 237 and 243 are two numbers. Both are 8-bit numbers only. Right. So what is our problem? We have to add two 8-bit numbers. Yes, I am adding two 8-bit numbers. But the problem arises when my result is going to be a 9-bit number. When my result is a 9-bit number, your microprocessor is an 8-bit microprocessor, your word size is 8 bits. So your accumulator can only hold 8 bits. The 9th bit cannot be stored in your accumulator. So what can I do with that bit? I have to store that bit in some other memory location. You understand, accumulator can only hold 8 bits. So whatever is there in the accumulator will be stored in result 1102. That carry bit has to be dealt separately. It will be stored at memory location 1103. Okay, sum and carry. Right. So let me repeat. We are adding two 8-bit numbers. Right. When you add two 8-bit numbers and if your sum of these two numbers is going to be 8 bits, then there is no problem, there is no carry. Whatever is there in the accumulator, you are going to store it in location 1102. But when I am adding two 8-bit numbers and my result or sum is going to be 9 bits. So maximum it can only be 9 bits. If my sum is going to be 9 bits, then what I do? What I do is I will store the sum in location 1102 and I will store the carry in location 1103. I will store the carry in location 1103. Yes, this is what we are discussing. Right. So this particular program is addition of two 8-bit numbers with carry. Because we are going to deal with carry also, it is going to be with carry. Yes. Right. Let me start. Line number 1, MVI C, 00. Yes, MVI move immediate. MV stands for move, I means immediate. Immediate here means immediate addressing. So what you should remember is whenever there is I in your instruction, which means the data will be present in the instruction itself. The data is going to be present in the instruction itself. In this case 00 is the data. You can see that in the instruction itself. So the previous program also I have told you that. So what do you mean by being in the instruction itself? For example, in LDA 1100, we are going to say the data is present in 1100. We load the data from 1100 to accumulator. Okay. The next line we are saying move B, A, wherein what is the meaning is the data is present in the accumulator. From there move it to B register. So we are saying either the data is in a memory location or we are saying the data is in a register. Okay. Instead of these two, you can also have the data in the instruction itself. So you are directly giving the data. You are saying move immediately C, 00. which means 0 0 will be present in the instruction itself. This is called an immediate instruction. So what is the meaning of MVI C, 0 0 is you are moving 0 0 to register C. It is like C is equal to 0 in C programming language, or say it's in Java. It's like you are initializing the value of C to 0. Right? So that's what we are doing here. Why do we need C here? C register is used to store the carry. In this particular program, we are going to use C register and store the carry in the C register. Okay. When will there be carry? As I told you, when you add two numbers and your result is more than 8 bits, then you will have a carry. Okay. So how are we going to deal with that in this program? Is we are going to have register C. If register C value remains to be 0 till the end of the program, then you say that there is no carry. If the value of C is 1, then you say that there is a carry. That's what you are going to conclude. Right? So how are we going to take the inputs? Let us see. LDA 1100. The first number is loaded from the location 1100 and it is moved to your accumulator. Yes, LDA 1100 means the first number, first input is going to be loaded from the memory location 1100 and it is going to be loaded into the accumulator. Right? MOV B, A. Again, the contents of the accumulator is moved to register B. The contents of the accumulator is moved to register B. Again, I am going to use LDA 1101. So, I am going to take the second input from location 1101. I am going to load it in the accumulator. So, here see, first I loaded the first number, it was in 1100, I loaded into the accumulator. Right? So, now I have to load the second number in another register, but there are no commands called LDB, LDC and so on. We only have one LDA. There is only one such command where you can move the contents of your memory register into the accumulator. There is only one command. That is why first time in line number 3 from 1100 I am taking the first number, loading it into the accumulator. Right? Then from accumulator I am moving that first number into register B. Right? Now I am going to load the second number again in the accumulator. So first number is there in register B, second number is there in the accumulator. Right? So what is the second number? Second number is 4, which is in the accumulator. First number is 3, which is in register B. So we have to add A plus B. We have to do addition A plus B. Right? But I will only say add B. I am not saying add A comma B. I will only say add B. Because any arithmetic and logic operation always involves your accumulator. Accumulator will always be that first operand. Okay. So, you only have to specify the second operand. So, already there is one number, second number is in accumulator. You only have to say where the first number is. Okay. First number is in register B. So, as soon as I say add B, it is going to add the contents of register B with the contents of the accumulator, and your result is going to be stored in the accumulator itself. I repeat it. Okay. Accumulator has the second number. The first number is in register B. When I say add B, B and A will be added together, and again the result is going to be stored in the accumulator itself, which means 4 is going to be added with 3. Okay, 4 is going to be added with 3 and the result 7 is going to be stored in the accumulator itself. So, the meaning of add B is, add B means add the contents of register B, yes, plus the contents of register A and store the result in the accumulator itself So, this is the meaning of add B. Okay. Not just add B, whatever arithmetic or logic operation you do that operation with an operand always with the accumulator, right, and store the result in the accumulator only. This is what you should remember. Right. So, we do this for our arithmetic and logical operations. Next is, I have added now. So, my only problem is I have added. I have to see whether my result has a carry or not. That's all. Right. If my result doesn't have a carry, no problem. I will just go store the result at 1102. There is no carry. So, C value is 0. That 0 will be stored in 1103 and I will come out of the program. If at all there was a carry, if at all there is a 9th bit, then I have to store that 9th bit in location 1103. So, that is my task. Okay. How will I find out whether there is a carry or not? I have to check the flag registers. To find whether there is a carry or not, I need to check my flag register. Okay, my carry flag will be 0 if there is no carry, and carry flag will be 1 if there is a carry. Okay, so jump no carry is my command here. It is a conditional jump command. Jump when there is no carry. Okay, if there is no carry, I am not having any issues. I will store my sum which is present in the accumulator to 1102. I am storing the sum to location 1102, and I am going to move C, which is 0, to accumulator, and again storing that in 1103. Okay, and I am going to halt. Okay, let me repeat that. When I am adding two numbers, if there is no carry, how will I know whether there is no carry? I have to check the C flag. Carry flag has to be checked. If the carry flag is equal to 0, then means I don't have a carry. So what I should do when jump and there is no carry, I will go to line number 9. In line number 9, what I should do, whatever the sum is present in the accumulator, that has to be moved to location 1102. So the sum is going to be stored in location 1102. Right? The next line, C's value is MVI C, 00 we did in their line number 2. So that 0 which is stored in C has to also be recorded somewhere. It also should be recorded somewhere. I want to put that, store that value in the location 1103. So what I will do, as I said, like LDA, there is only one STA, there is no STB, STC. So you have to, whatever you have to store it in the memory location. First, that particular register value has to be moved to the accumulator. From the accumulator, it will be moved to one of the memory locations. That is the only option we have. So we are going to say MOV A, C. So the carry or the contents of register C is moved to accumulator. From accumulator, it is going to be moved to address location 1103. So 1103 will have your carry and 1102 will have your sum. Halt. Right? Same thing. Let us go back to line number 6. I am adding A and B. Okay, I have a carry, which means the carry flag is set. C is equal to 1. Okay, when I check jump on no carry, skip. Okay, that becomes false because there is a carry. If there is no carry, I have to jump to line number 9. I have to jump to skip statement. But if there is a carry, I have to just proceed with the flow of the program, which means I will move on to line 8. I will not skip line 8. I will move on to the next line. Next line, you have a command called INRC. INR stands for incrementing C. INR means increment C. So also remember, INR command can only increment 1. Okay, or in other words, the meaning of INR is C is equal to C plus 1 or C plus plus. Right? So however you want to put it, C is equal to C plus 1. Increment will always increment only by 1. Okay, you cannot increment by 5, 10 and all that. Increment command can only be used to increment it by 1. Okay, so I have used a comment statement here. The semicolon means comment. So I am just giving you an explanation of what do you mean by INRC. INRC will just add 1 to your register C. Okay, now your C register has become 1, which means there is a carry. Okay, there are only two possibilities. The 9th bit can be 0, which means there is no 9th bit. The 9th bit can be 1. Okay, the 9th bit is 0, so it's going to be C is equal to 0. If the 9th bit is going to be 1, then we are going to increment C, so it making C 1, and then what you are going to do, you are going to store that C in location 1103. So that is what we should be doing. So increment C will increment 1 to register C. Next line, as usual, whatever is the contents of the accumulator, store it in 1102. Okay, then MOV A, C. So now C is value is 1. Since there is a carry, C value is 1. So that 1 is going to be moved to the accumulator. From accumulator, you are going to move the value of C, which is the carry, to 1103. Okay, 1103 will now contain the carry. Right? HLT, halt the program. So I have already shown you an execution for two numbers which doesn't have a carry. Let me again now come up and show you one example. The same example which is here, I will show you the same example with carry. Okay. So when will there be a carry is a question now. For you to give two numbers, you should know what numbers should I give as input so that I will get a carry is the question now. Okay, the answer is very simple. Using 8 bits, I can only represent numbers between 0 and 255. Okay. Using 8 bits, what I can do, I can only represent numbers between 0 and 255. If your sum, if you add any two numbers, and if your sum is going to exceed 255, if your sum is going to be more than 255, then obviously you will get a carry. Then obviously you are going to get a carry. You understand? So let us take two examples here. So 237 I am representing in binary, and I am going to represent 243 also in binary. Actually, when I add these two, what should I get? 7 plus 3 is equal to 10, carry 1, 8, 4, 80 is what I should get. But I am getting 224. Why? Because, okay, why I will tell you. Why? Because we are not going to completely convert the whole 9 bits. We will only convert 8 bits, because your accumulator only can store these 8 bits. The value of these 8 bits means it is 1110, 0000 means 224. Okay, that one we are not going to convert now. We are simply going to store it in carry in a different memory location. That is why your result is 1 in 1103 and 224 in 1102. Because whatever was there in the accumulator can only store 8 bits. So only these last 8 bits would have got stored in the accumulator. Okay, that value in the accumulator only we are going to pass it to this memory location 1103. So it will only have the converted value of 8 bits, which is 224. Right, and that one carry is going to be stored in 1103. You understand? Right, though the sum is more than 255, but your accumulator again can only store up to 255. So it will divide it like this. 8 bits will be converted, and that will be stored in location 1102, and that one carry will be stored in location 1103. You understand? This is going to be a program for adding two 8-bit numbers. Yes. So as we see this program, the same program, if you just change ADD into SUB, this becomes subtraction program. Let us see how that happens, how it works, right? Same program, no change in the program. Only line here we will include as SUB. Okay, SUB is the only change, otherwise it is the same program. Okay, here what is the logic is, I will take two numbers 5 and 4. Let us say I am going to take two numbers 5 and 4. So if I am going to subtract 4 from 5, if I am going to do 5 minus 4, then my result is plus 1, no problem. Plus 1 is going to be your result. What if my result is a negative number? What if my result is a negative number? Right? My result is a negative number. The negative numbers in 8085 are going to be represented using 2's complement form. The negative numbers in 8085 will be represented using 2's complement form. That is one thing you should remember. Okay, if I am trying to subtract 5 from 4, so it is going to, your answer is going to be minus 1, which is going to be a negative number. Minus 1 has to be represented in 2's complement form. How will I represent minus 1? So if I am going to represent in minus binary, minus 1, so see, let us say I have a number, it is going to be minus 1. So the sign bit is going to be 1, which means it is a negative number, and the number my output is going to be 1 only. Right? So I have to find the 2's complement of it. How will I find the 2's complement? I have to find the 1's complement, right? And add 1 to it. So that's what I'm going to do. I have found the 1's complement now. I'm going to add 1 to it, right? So this is just a workout I'm showing. So my output will be 1, 1, 1, 1, 1, 1, right? If it is a negative number, I have to take the result and find the 2's complement of it. Okay, my result is minus 1. Okay, so I take that 1 as my result, and I am going to find 2's complement of 1. So when I do that, it means my output, whatever I get, my result, whatever I get, is going to be negative number in 2's complement form. That will be the negative number which I got, but it will be in the represented using 2's complement form. Okay, so the same program, I don't have to again explain you. Let me only give you two numbers and let us find out what is happening. Okay. First I am giving 4 and 5. Right. Let me first assemble the code and execute it. Right. 4 and 5, your answer is plus 1. So no problem. Okay. How did you get plus 1? The first number will be loaded in location 1100. That has to be again moved to B. So now B will contain 4. The second number will be loaded in accumulator. So A will contain 5. When you do 5 minus 4, A minus B, it will be 5 minus 4. So your answer is plus 1. So you don't have to worry about it. You only have plus 1. You have to put that plus 1 at location 1102. Right? So whenever you are going to have a negative number, let us see what is happening. So I am going to give two numbers. So I am going to the two numbers should give me a negative output. So I am going to give 5 and 4, which means it will try to do 4 minus 5 and your output will be minus 1. It will not come as minus 1, instead it will come in 2's complement form. Your output will be in 2's complement form. Right? So you saw this. So 5 and 4 I have given. So it will try to do 4 minus 5. Your output is minus 1. So it is going to be 255 because minus 1's 2's complement form is 255. I just showed you how you got 255. Right? And what does this 1 mean? Since it is a common program, here in this case 1 means it is a negative number. That's it. Okay? 1 means it is a negative number. There is also another inner meaning to 1. Since here you can see that, see I told you only when you get a carry flag will be set. You would have studied that in flag registers. Okay, I did a subtraction here. Why is the carry flag set? Maybe your question. Okay, there is a hidden information, that is your carry flag will be set even when there is a borrow. When I have to subtract 4 minus 5, I will have to borrow, right? So only then I can do the subtraction. So that is called as, that will set the carry flag, because carry flag is also used for borrow. Okay, carry flag is also used to represent borrow. That is why you have C is equal to 1 here, carry flag is set. Since carry flag is set, obviously the logic of the program is going to put 1 here. Okay, but what is the meaning that we are going to take in subtraction is, when we subtract two numbers, when the output is negative, first thing what will happen is the output will be represented in 2's complement form. Second thing what will happen is 1103 you will have a borrow. What is a negative number? At 1103 you will have a borrow. Yes, so this is how you subtract two numbers. So this program is going to be same as that of addition program, same logic, but this program is going to be used for subtraction of two 8-bit numbers. You understand? Yes. Thank you.